Welcome to episode 28. Today we are building our first final project, a complete student grading system. This real-world application will bring together everything you've learned: object-oriented programming, data structures, file handling, and more. We'll create a system that can store student information, calculate grades, generate reports, and manage multiple students. This is where theory meets practice. Let's build something amazing. Let's start with an overview of what we are building. Our student grading system will be a comprehensive application that helps teachers manage student grades efficiently. It will calculate averages, assign letter grades, track multiple subjects, and generate detailed reports. Our system will have 7 powerful features. First, store complete student information including names, IDs, and grades. Second, automatically calculate average scores. Third, assign letter grades based on percentages. Fourth, support multiple subjects per student. Fifth, generate beautifully formatted reports. Sixth, manage multiple students in a class. And seventh, find top performers and calculate class statistics. This is a professional grade application. Let's start building. The heart of our system is the student class. This class will encapsulate all student data and behavior using object-oriented programming principles. We'll use the init method to initialize student data, store grades in a dictionary, and add methods to manipulate that data. Here's the foundation of our student class. The init method takes a name and student ID as parameters. We store these as instance variables using self. The grades dictionary will map subject names to scores. For example, math could be 95. Science could be 88. We also add a string method to get a nice representation of the student when we print them. This uses an F string to format the output nicely. Notice the doc strings, these explain what each method does, making our code professional and maintainable. Now let's add methods to manage grades. We need a way to add grades for different subjects and retrieve them later. These methods will interact with our grades dictionary. The addGrade method takes a subject and a grade. First, we validate that the grade is between 0 and 100 using an if statement. If it's not valid, we raise a value error with a descriptive message. If valid, we store it in our grades dictionary using the subject as the key. We also print a confirmation message. The getGrade method retrieves a grade for a subject. We use the dictionary's get method which returns none if the subject doesn't exist, preventing key error exceptions. This is defensive programming, anticipating potential problems. Next, we need to calculate the student's average grade. This is a crucial feature that will sum all grades and divide by the number of subjects. We'll handle the edge case where a student has no grades yet. The calculate average method computes the mean of all grades. First, we check if the grades dictionary is empty using not self.grades. If empty, we return 0 to avoid division by 0 errors. Otherwise, we use the sum function on grades.values to add all the scores. We get the count using len of grades. Then we divide total by count to get the average. Finally, we round to 2 decimal places for clean output. This method showcases Python's built-in functions, sum, len, and round, making our code concise and readable. Now for the letter grade. We'll convert numerical averages to letter grades using the standard grading scale. This method will use conditional logic to determine A, B, C, D, or F based on the percentage score. The getLetterGrade method uses a classic if-else chain to assign grades. First, we call calculateAverage to get the numerical score. Then we check thresholds from highest to lowest. 90 or above gets an A. 80 to 89 gets a B. 70 to 79 gets a C. 60 to 69 gets a D. Below 60 gets an F. The order matters here. We check highest first because once a condition is true, Python skips the rest. This is the standard American grading scale. But you could easily customize these thresholds for different systems. Finally, let's create a method to generate a formatted grade report. This will display all the students' information in a professional, easy-to-read format. We'll use string formatting and alignment to make it look polished. The generateReport method builds a formatted string step by step. We start with a line of equals signs for visual separation, using string multiplication with a star operator creates 40 equals signs. Then we add the student's name in uppercase using the upper method for emphasis. We add the student ID. Another separator line. If there are no grades, we show a friendly message. Otherwise, we prepare to list all subjects. The minus signs create another visual divider. Each line uses plus equals to append to our report string. The \n characters create line breaks for proper formatting. Now we continue building the report by iterating through all subjects and grades. Then adding the calculated average and letter grade. This completes our professional-looking report. We iterate through grades.items to get each subject and grade pair. The formatting here is special. We use :<20 to left align the subject in a 20-character field. We use :6.1f to right align the grade in a 6-character field with 1 decimal place. This creates beautiful columns that line up perfectly. After listing all subjects, we add another separator, then show the average with 2 decimal places and the letter grade. A final line of equals signs completes the report. We return the complete string, ready to be printed or saved. Now let's build the gradebook class. This will manage multiple students, acting as a container for our entire class. It will store students in a list and provide methods to add students, find them by ID, and generate class-wide statistics. The gradebook class starts with an init method that takes a class name, like Mathematics 101 feet or Biology Advance. We initialize an empty list called students to store all student objects. The addStudent method takes a student object and appends it to our list. We print a confirmation message showing which student was added to which class. Notice we are storing the actual student objects, not just names. This gives us access to all their methods and data. This is composition in action. Gradebook contains student objects. Next, we need methods to find students and remove them from the gradebook. Finding students by ID is crucial for looking up their information quickly. We'll also add a method to remove students who may have transferred out of the class. The findStudent method searches through all students using a for loop. It compares each student's ID to the one we're looking for. When it finds a match, it returns that student object immediately. If the loop completes without finding anyone, it returns none. The removeStudent method uses findStudent first to locate the student. If found, it removes them from the list using the remove method and prints a confirmation. It returns true for success. If not found, it prints an error message and returns false. Returning Boolean values lets the calling code know if the operation succeeded. Now let's add powerful analytics. We'll calculate the class average. Find the top performers and get the student with the highest average. These methods showcase data analysis using Python. The get class average method calculates the mean of all student averages. First, we check if there are any students. If not, return 0. Then we use a generator expression inside sum to call calculate average on every student. This is concise and memory efficient. We divide by the number of students and round to 2 decimals. The get top student method finds the student with the highest average. We use Python's built-in max function with a lambda function as the key. The lambda tells max to compare students based on their average grade. Max returns the student object with the highest value. This is functional programming in action, using functions as arguments. Let's add a method to get all top performers, students who meet or exceed a certain average. This is useful for honor roll lists or identifying students who need recognition. The get top performers method takes a minimum average parameter with a default value of 90. We use a list comprehension to filter students whose average meets or exceeds the threshold. This creates a new list containing only qualifying students. Then we sort this list using the sort method with a lambda key function. The reverse equals true parameter sorts from highest to lowest so the best student appears first. We return the sorted list. This method combines filtering and sorting in just a few lines, demonstrating the power of Python's data manipulation capabilities. Finally, let's create a comprehensive class report that displays all students and overall statistics. This will be the centerpiece method that showcases all the data in a beautiful format. The generate class report method starts by creating a header with the class name in uppercase. We add basic statistics, total number of students using len, and the overall class average using our get class average method. If there are no students, we show a friendly message and return early. This prevents trying to process an empty list. The formatting uses equal signs for visual impact, making the report professional and easy to read. Now we continue the report by listing all students with their grades and identifying the top performer. This completes our comprehensive class overview. We add a student rankings section with a separator line. Then we sort all students by their average using the sorted function with a lambda key. This creates a new sorted list without modifying the original. We use enumerate starting from 1 to get ranking numbers. For each student, we calculate their average and letter grade, then format them in aligned columns. The formatting creates a professional leaderboard showing rank, name left aligned in 20 characters, average right aligned with 2 decimals, and letter grade in parentheses. Finally, we highlight the top performer and close the report with a separator. This gives special recognition to the highest achieving student. We call get top student to find the highest achiever. If one exists, we add a special section with a star emoji for visual emphasis. We display their name and average. A final line of equal signs closes the report professionally. We return the complete string ready to be displayed or saved. This report method brings together all our data into one comprehensive view, perfect for teachers or administrators. Now let's see our system in action. We'll create students, add grades, and see how everything works together. This demonstrates the practical application of all the code we've written. First, we instantiate a gradebook object for Python Programming 101. Then we create 3 student objects, Alice, Bob, and Carol, each with a name and unique student ID. We add each student to the gradebook using the add student method. Each edition prints a confirmation message. Now our gradebook contains 3 students ready to receive grades. Now let's add grades for different subjects to each student. This populates our system with real data that we can analyze and report on. We add grades for 4 subjects to each student using the add grade method. Alice gets high scores, 95, 92, 88, and 94. She's an excellent student. Bob has moderate scores in the 75 to 82 range, solid but not exceptional. Carol scores in the high 80s to low 90s, very strong performance. Each add grade call validates the score and stores it in the student's grades dictionary. Notice the different subjects: Python basics, data structures, algorithms, and web development. This demonstrates how our system handles multiple subjects per student. Let's generate individual student reports to see their complete grade information. Each report shows all subjects, the calculated average, and the letter grade. We call generate report on Alice's student object. The output shows a beautifully formatted report with her name in the header. Student ID. All 4 subject grades aligned in columns. The calculated average of 92.25. And her letter grade of A. The equal signs and dashes create visual sections that make the report easy to read. This is professional output suitable for printing or sending to parents. Each student can generate their own custom report with all their specific data. Now let's use the gradebook's analytics features. We'll find the top student, get the class average, and identify all top performers. This showcases the power of our data analysis methods. First, we get the class average using getClassAverage. It returns 87.33. A solid B average. Then we find the top student using getTopStudent. Alice Johnson with her 92.25 average leads A class. Next, we get all top performers with averages 90 or above using getTopPerformers. 2 students qualify, Alice and Carol. We iterate through them and print their names and averages. This creates an honor roll list. These analytics methods turn raw grade data into actionable insights for teachers. They can quickly identify high achievers, track class performance, and recognize students who deserve special acknowledgement. Finally, let's generate the comprehensive class report. This brings together all students and statistics into one complete overview, the crown jewel of our system. We call generate class report on the gradebook object. The output is spectacular. It shows the class name, total student count of 3, and class average of 87.33. Then it lists all students ranked by performance. Alice first with 92.25 and an A. Carol second with 90.75 and an A. And Bob third with 78.75 and AC. Finally, it highlights Alice as the top performer with a star emoji. This single report gives teachers a complete snapshot of class performance. They can see who's excelling, who might need help, and overall class health, all in one beautifully formatted display. Let's explore some additional features that make our system even more powerful. These demonstrate the flexibility and extensibility of well-designed object-oriented code. Our system includes robust error handling. First example, trying to add an invalid grade of 105 raises a value error that we can catch with try except. The error message clearly explains the problem. Second example, searching for a non-existent student ID returns none, which we can check before proceeding. This prevents crashes. Third example, removing a student returns a boolean indicating success. We can verify the operation worked and check the new class size. These patterns make our system reliable and user-friendly. It handles mistakes gracefully instead of crashing. One of the beauties of object-oriented design is extensibility. Let's explore how you could expand this system with additional features. These ideas demonstrate the scalability of our architecture. First extension idea. Add file persistence. You could save the entire gradebook to a JSON or CSV file and load it later. This code shows how to convert student data to a dictionary structure and save it as JSON using Python's JSON module. The with statement ensures the file closes properly. You'd need a corresponding load method to read the data back and recreate student objects. This would let teachers save their work and continue later, essential for a real application. Second extension. Grade distribution analysis. This method creates a dictionary to count how many students received each letter grade. It initializes counters for a through F at 0. Then iterates through all students, getting their letter grade and incrementing the appropriate counter. The result shows the distribution. Maybe 2 A's, 1 B, 1 C, and so on. This helps teachers understand overall class performance at a glance and identify if the class is struggling or excelling. Third extension. Subject-specific analysis. This method calculates the average grade for each subject across all students. It uses 2 dictionaries to track totals and counts for each subject. As it iterates through every student and their grades, it accumulates the totals and counts. Finally, it uses a dictionary comprehension to compute each subject's average. This reveals which subjects students find easy versus difficult. Maybe everyone excels at Python basics but struggles with algorithms. Teachers can use this to adjust their teaching focus. Fourth extension. Student alert system. This method identifies students at risk of failing by finding those with averages below a threshold. Default 70. It uses a list comprehension to filter students, then sorts them by average with lowest first. Teachers can quickly see who needs intervention. The example usage shows how to print a support list. This proactive approach helps teachers reach struggling students before it's too late. Early intervention can make the difference between passing and failing. Here are even more extension possibilities. Weighted grades where finals count more than homework. Email integration to automatically send reports to students or parents using Python's email libraries. Semester management to track performance over multiple terms and show trends. A graphical user interface using Tkinter or Pyqt so teachers can click buttons instead of writing code. The possibilities are endless. Our solid object-oriented foundation makes all these extensions feasible without rewriting the core system. Let's review the software engineering best practices we applied in this project. These principles make our code professional, maintainable, and scalable, qualities that distinguish hobbyist code from production-ready software. We used encapsulation by bundling related data and methods in classes. Students own their grades and know how to calculate averages. Single responsibility means student handles student data while gradebook handles collections of students. Each has one job. Defensive programming validates all input like checking grades are between 0 and 100. The dry principle means we wrote calculate average once and reuse it everywhere. Clear documentation with docstrings explains what each method does. Meaningful names like add grade and get top student make code self-documenting. These aren't just theory, they're practical techniques that make code better. Let's visualize the complete architecture of our student grading system. This diagram shows how all the pieces fit together: the classes, their relationships, and the flow of data. Here's our architecture. The student class on the left has attributes for name, ID, and a grades dictionary. It has methods to add grades, calculate averages, get letter grades, and generate reports. The gradebook class on the right has a class name and a list of students. It has methods to manage students and generate analytics. The green arrow shows the relationship. Gradebook contains multiple student objects. This is composition. Gradebook is composed of students. Let's look at what we've accomplished. These statistics show the scale and complexity of the system we built together. This is a substantial, real-world application. We created two main classes, student and gradebook. We implemented over 15 methods covering everything from basic operations to advanced analytics. We wrote over 200 lines of well-structured, documented code, and the possibilities for extension are infinite. This isn't a toy project, it's a professional application that could be deployed in real schools. With some additional features, you should be proud of what you've built. Let's recap the most important lessons from this project. These takeaways will help you build your own applications and understand how to structure complex systems using object-oriented programming. First, object-oriented programming lets us model real-world concepts like students and gradebooks directly in code. Second, classes encapsulate related data and behavior. Students own their grades and know how to calculate averages. Third, methods can call other methods, generate report uses, calculate average and get letter grade internally. Fourth, input validation prevents bad data. We check that grades are between 0 and 100. Fifth, data structures like dictionaries for grades and lists for students organize information efficiently. Sixth, careful string formatting creates professional-looking output that users appreciate. Seventh, extensible design with clear class boundaries lets us add features without rewriting existing code. Finally, real projects require planning. We designed our classes before coding. This project brought together numerous Python concepts. Let's celebrate all the skills you've demonstrated by building this complete application. You are becoming a real Python developer. You mastered object-oriented programming with classes, objects, instance variables, methods, and special methods like init and str. You worked with data structures, dictionaries to map subjects to grades, lists to store multiple students, and techniques to iterate and manipulate them. You used control flow with if, else for grading logic, for loops to process collections, and list comprehensions for filtering. You created functions and methods with parameters and return values, used lambda functions for sorting, and leveraged built-in functions like sum, max, and sorted. These are professional level skills. And there's more. You also mastered string manipulation, error handling, and software design principles. These additional skills round out your Python expertise. You mastered string manipulation with f-strings for clean formatting, alignment for columnar output, and building multi-line reports. You implemented error handling with input validation, raising exceptions for invalid data, and defensive programming that prevents crashes. You learned software design including how to structure classes, apply encapsulation principles, and organize code logically. Most importantly, you developed problem-solving skills, breaking complex problems into manageable pieces, thinking algorithmically about solutions, and the patience to test and debug. These meta skills transfer to any programming language. Congratulations on completing this major project. But the learning doesn't stop here. Let's discuss how you can build on this foundation and continue growing as a Python developer. First, implement some of the extensions we discussed: file saving with JSON, a GUI with tkinter, or email reports. This will deepen your understanding. Second, customize the system for your specific needs. Maybe your school uses different grading scales or has unique requirements. Third, build similar projects to reinforce these concepts: a library management system, inventory tracker, or personal expense manager all use similar patterns. Fourth, share your work. Put it on GitHub to build your portfolio. Show it to teachers, or include it in job applications. Finally, learn advanced topics like database integration with SQLite, web frameworks like Flask or Django, or building apps. You have the foundation, now build your tower. Congratulations! You've completed a major milestone in your Python journey. You built a complete, functional student grading system from scratch using professional programming techniques. Look at what you accomplished. You designed a multi-class system with clear responsibilities. You implemented over 15 methods handling everything from basic operations to advanced analytics. You applied object-oriented programming principles like encapsulation and composition. You created professional, formatted output that looks polished. Most importantly, you built something real and useful that could actually help teachers manage their classes. This is no longer toy code, this is a real application. But remember, this is just the beginning of your journey. You've proven you can build real applications. Keep coding, keep learning, and keep building amazing projects. Every line of code makes you better. Every project teaches you something new. The world needs developers like you, people who can take an idea and turn it into working software. You have the skills. Now go create something incredible. Thank you for joining me on this journey. See you in the next project. Episode 28 complete. You've built your first major final project, the student grading system. Share your accomplishment with these hashtags and show the world what you've created. Until next time, happy coding.